Hello again, science students. Mr. Zana here with your next lesson. Today we're still in Unit 6. We're dealing with topographic maps. This is your introduction to them. So today we're learning about topographic maps and their features. We're going to be doing this by learning what topographic map is and what features are found on them. Why? Well, this is going to allow us to interpret topographic maps and determine what each shape represents on the map, so we can then transfer that learning to our understanding on how our planet looks from space. Remember, this is going to connect with our lessons on divergent, convergent, and transformative plate boundaries, because that is what causes features on our planet. And now we're learning how to read those features on an actual map. So, champs today. Virtual, read these on your own in person. Voices are off while I'm presenting or Ms. Konopik's presenting. Raise your hand for help. We're covering topographic map features. You need to be seated, or if you're having difficulty staying awake, you can stand by your desk. Participation is always required, and if we do all these things, we'll be successful. Here's the Unit 6 unit organizer again. We're right over here. We're talking about topographic maps. We're going to be discussing a few more of our vocabulary today. And we're going to be doing a bit of at least in class, we're going to do a bit of a review on divergent, convergent, and transformative plate movements. As always, you should be updating your unit organizer as we go along. Right here, it says we should be able to discuss what these represent by the end of our class. You should have this area here filled out already. These are divergent, these are transformative, and those are convergent. You should have this done as well, dealing with both of our theories from Admiral Hess and Mr. Wegener. So here we go, introduction to topographical maps. Topographic maps, these can be used to interpret the Earth's features and predict future changes to these features. So it'll allow us to look and see what we see today, but over time, topographic features change due to weathering or erosion. So you'll be able to compare them in the future. These are maps that show the slope, shape, and elevation of land's surface using contour lines, which we'll get into contour lines here in a minute. But these are what tells us how steep or how gradual a slope is. So here we go with contour lines. Contour lines, here we go. Contour lines, this is a map symbol that shows the shape and or change in elevation on a topographic map. So one contour line represents the elevation for that entire line. So if we're looking at this line here on the outside, see how it's all the way around? That one line, if I put a 50 here, 50 feet, that means the whole line is at a 50-foot elevation, okay? So widely spread lines like these two here show a gradual or gentle slope, while closely spaced lines like these ones over here represent a steep grade or slope. So this is a mountain, and if you were looking to take a hike, it would be important to have a topographical map that you'd be able to look and go, well, gosh, I don't think we should come up this side of the mountain because it's just so steep. You would obviously rather come up the gradual slope. It would be safer and less strenuous on your group, depending on how old or young your hikers were. So contour lines that form closed circles around the top of hills and mountains. So you'll see here that this picture is of a mountain. Okay, it's actually of two peaks. See how we have one in here and one in here. So these lines closing a circle shows that it's a mountain or a hill. Now, moving outward from this inner circle, the very inner circle going outward is going from the top of the hill, going downhill. So the very innermost circle here in this line, this is the peak, and we're working our way downhill. Closed circles with short, straight lines inside the circle indicate depressions. So see, this is a mountain, and this is the top of the mountain, and we work our lines outward, which is going downhill. But as you can see, these are little short lines inside, show a depression, which means it may have a bit of a sinkhole or some type of other depression at the top of that mountain. Okay, here are contour lines again. This will give you an idea. So these are contour lines. Right here, show you the elevation number here, 100. Okay, and then you have the index contour, and this is where you would start an index, which we're not going to cover. But so the contour line here are the ones that are going to have the contour interval, as it's called, on it. And we're going to get into contour interval in just a second. So contour lines crossing a valley or stream are V or U shaped. The closed end of the V or U points uphill, and the open end indicates the direction of water flow. So see how these U's, this is the closed end, this is showing uphill. So this direction's uphill, and seeing that this is open, 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 this is showing the water's going that direction out to the ocean. That's why we have that arrow there, is just showing you that flow. The arrow's not normally there. Put it there so you'd realize where that water flow was going. Here's the contour intervals I was talking about just a moment again. This is the difference in elevation between two contour lines on a topographic map. So in this one, you can see that the interval, you see this here, you have one line, then this one, then this one, this one. So if you look, you can tell that this one to this one is a 20 jump, which means there's a line between, which you can then divide and go, well, they're 10, whatever the measurement is on this, let's say 10 feet intervals. So this would be 10, 20, 30, 40, 50, 60. You don't have to label every line. If you decide that you are going to do intervals on your lines, it's best not to put them on every line because it clutters up your map. So if you're doing it by tens, you can just go ahead and put 10, 20, 30. That would be cluttering. But if you do it by 20, 40, 60, it's going to make the map look a little cleaner, but you can infer what the interval is just based on how many lines you have between each of these two numbers. All right. If you know the contour interval, you only need one contour line labeled to know what the elevation of the other contour lines are. For example, if D is 100 feet, so here's D, if this line right here is 100 feet, and a contour interval is told you is 50 feet, then you can figure out what C, B, and A are. So you can say, well, they're 50 feet, so 50, that'd be 150, and C here would be 200, 250, 300 for B, 350, 4, 450, 5, 550. A would be 550. So based on knowing what the contour interval is and having one contour line labeled for you, you should be able to determine the rest of the elevations for that map. All right, now we're going to talk about erosion. This is simply the weathering of topography by primarily wind and water. Okay? Erosion, there are many features of our topography that are affected by erosion, such as canyons, deltas, mountains, rivers, islands, and our coastline, just to name a few. There are so many more. There's more than a dozen. But these are some of the more common ones. So when rivers or streams erode, they become straighter as the bends and turns are parts that are eroded away. So if you have a really curvy river, over time, the water, when they have floods and when they have melting snow or big rainstorms, will erode the corners away of that river and it'll become straighter. You can always spot an old river by how straight it is. So here we have an example. You can see that the oldest river below would be X as the bends are nearly gone. See? Nearly gone, almost straight. Our coastlines are also being constantly eroded. The waves crashing against the shore erodes the beach or cliff it is washing up against. The part of the coastline most directly hit by these waves will be eroded the fastest, followed by inlets and bays. So the beach that faces directly to the ocean will take the brunt of the heavy rainstorms and storms coming in, the larger waves. It will face more erosion quicker than, say, a bay that's inside, protected a little bit by maybe a little bit of land or maybe a mountain. But even the bays will eventually erode because even they will get erosion from waves, just not as large as what you'd have right on the coastline. Craters, such as the Meteor Crater in Arizona. My son and I went there this summer. They're also affected by erosion. Over time, the rim surrounding the crater will erode, causing the crater to become more shallow. So here's a picture of the crater in Arizona, and it's really very deep. They don't allow any tours down inside the crater anymore, but you can, as you can see, be up on the rim and take pictures, and they have binoculars and stuff up there that you can use to see what's going on and what they have down there at the bottom of the crater. But over time, these areas, the rim, will get eroded and leveled off more and more, which will make this crater less deep. It'll become more shallow. All right, so next class we will be learning how to draw map features such as contour lines. We'll be doing a worksheet and a really cool lab. And basically, it's worksheet time. So we have a worksheet to help you better understand topographic maps and some of the features. So please complete the worksheet that is attached to this Google assignment. If you're virtually learning, those of you in class, you're going to be working in small groups. All right? Well, until next time, this is Mr. Zana saying, love your science.